How you can find volume of revolution using GeoGebra. So in GeoGebra, basically, it's not difficult. I'm going to show you simple way of kind of plotting the function and also kind of revolving it along the x-axis. As far as you know one above the x-axis, you should be able to know how you can revolve it along the y-axis as well, and maybe even a line, right? And then after that, you have to know a little bit of your mathematics, because whatever function that you are going to put inside, you have to it has to be expressed in terms of the approximated area, and then it should be integrated over the particular limit that you find. So therefore, I'm trying to say that, for example, if you are being given or if you are given two functions to kind of revolve along the x-axis, then it means that two functions that you have been given, you have to know their exact meeting points, right? In that case, you'll be able to know the exact area under the two curve, right? And when you revolve it along the x-axis, for instance, you have to find the expression for the inner area and the outer area, and then after you find those ones, and then you put them inside your GeoGebra command line or the input command line, and then press enter to find your exact volume. So let's quickly go ahead and see what we can do. So for this side, we are going to plot the function y equal to x to the power 1 over 3, right? So you go to the input part, so function. As soon as you do the function, you can see that there are a lot of other commands that appear over there. So those commands, do well and pick the second one, right? You can decide to plot the function itself, but it will go up to infinity. You don't know where it will end. That's why I was saying that you should know where the two functions meet in such a way that you can limit the points on the graph that may be of importance to you. So in doing that, what you can do is that you select the one here. So for the x equal to y equal to x to the power 1 over 3, and then let's say y equal to x over 4, per the calculation that I did here, when you do the meeting point, it should be from 0 to 8, right? So let's us visualize it so that you can see. Let's say for x to the power into brackets 1 over 3, that's 1, and then the limit will start from 0 to, let's say, 8, right? So when that happens, that's and then you should do that, and it seems that we are missing something. They say imbalance brackets. So let's check where we are missing our brackets, and it seems that our brackets, this is the point where we are missing our bracket. You can see that it has appeared, and now the function is no longer going to infinity, right? Assuming that I plot the function and I don't limit it, it will go to infinity, right? It will be going. I don't know where it will end, but since I'll know the meeting point, I'll be able to draw it up to this point, and I'll press enter. So let's quickly do same for the other one, y equal to x over 4. Let's say the same thing. We type function, and then you pick the second one, and then you type it there, x over 4 as a function, and then the next one will give us let's say 0, and then same points, let's say 8. So you can see that they are meeting at that point. That's why I was saying that you should know where the two functions meet, so we can calculate it by equating it algebraically. So for example, let's say x equal to 1 over 3 equal to x over 4, or you can do it in terms of y, and you can find its corresponding x values, and therefore you'll be able to use it. If you are revolving it along, let's say, the y-axis, then you'll be able to find the y value straight away. But if you are revolving around the x-axis, that means that you have to find the y value. That may be a simple way to find it. When you get it, you come and put it inside any of the functions to find the x values. So in this case, because I've already done it, I'm putting in the limit straight away from 0 to 8. That's where I know that they will meet. And then you do same. Now that we have this figure, we have to revolve this one along the x-axis. So how do we do that? So this is what you can do. You go to this point, view, and then you go to 3D, right? So when you go to view and you go to 3D, you can see that the 3D graphic has appeared, right? You can decide to bring in the grid, right? Also, you can see that the grid is showing over there. Yes, showing over there. The grid is showing, and then what you can do again is that you have to revolve it, right? You have to revolve it. So what you can do is, because it's already in 3D, if it's not in 3D, what you can do is that you go to this point. Have you seen this point? And you go to surface of revolution, right? So when you go to surface of revolution, so come here, you go and click on the you click on the axis of rotation. When you're done with the axis of rotation, then you click on each curve one after the other. So I can click here and it will revolve along what the x-axis, and I can also click here and it will revolve along what the y-axis. So in that case, you have been able to revolve this function. So you can, let's visualize it well. Let me go here and then put it here and then rotate the wall so that you can see. Let me put this one. Yes, so you can see that this is the volume that we are interested, because when we use the washer method and the disc washer method, that is, we approximate this whole figure into a circular hot disc, and after approximating into a circular disc, then we use what the outer radius minus the inner radius or square and then multiply by this one and find the integration over that particular expression, and you find the volume of this particular figure. So in that case, this is a simple way of revolving a function along the x-axis. You can do same for the y-axis, right? You can do same for the y-axis as well, by using GeoGebra. So when you get it this way and you want to kind of, let's say, find a volume revolution, some people decide to find a type volume straight away, but mostly I don't advise students to do that. But what you can do is that we know that the expression is what there are two functions. You know that it's pi and the integral of, right? It's pi and the integral of. So how do we do that? So you can do pi, right? And then for the pi, multiply by, let's say, integral, or you can start let's go straight away. You can type integral, right? So integral, you can see that integral comes to the function, the start value and the end value. You can click there, and then we know that our outer radius will be what the outer function, right? So the outer function is what x. When you look at here, then go to the outer function is this one, right? So it will be our x to the power 1 over 3. Right, that will be our outer function. So in that case, you can decide to type your outer function over here, x to the power into bracket 1 over 3, and you have to be careful of unbalanced brackets, right? And don't forget that this one is all squared, right? That is the outer function, and then minus let's say minus the inner function, and the inner function is what x over 4, right? And don't forget that is into brackets x over 4, and then that one too, it's all squared, and then don't forget to close the bracket as well. And based on this, we can decide to bring our pi, for example, let's say our pi out here, right? Multiplying by our pi out here, and then let me get here and then close the bracket as well. So we can go here, and the limit is from 0 to 8, right? And based on that, you click, if everything is fine, you click enter. And when you look at this one, they say that unbalanced bracket. Yes, we have another issue with unbalanced brackets. So let's quickly try and balance the brackets, right? Let's try and balance the brackets. Let's eliminate this and let's see how it goes, right? Yes. So let's see what we are getting. Let's see what we are getting, right? So for the volume of revolution, that's what we got, right? So this is what we got. So if everything is fine, we have into bracket pi is there, and you can see that we have into bracket the function, the outer function x to the power 1 over 3 all squared minus the inner function x over 4 all squared, right? And that is there, and the pi is multiplied by it, and it's from 0 to what 8. You can do same for what on the y-axis or even on the line. So you can also decide to kind of edit the functions in case there's anything. You can double click on the function up there and then do your edits. You can change also the limits to whatever you want as well. For the revolution that we did over here, you can also try and kind of change the angle of revolution. For example, I want to rotate it up to, let's say, 270. So for 270, you should be able to do that. And when you turn this one, let's see what we have been able to do. So you can see that I've been able to rotate it. Let me zoom it more. Right, I've been able to rotate it. You know, it was able to rotate up to this point, you know, from one side to the other point, but the other ones were not open over there yet. As you can see, yes, they have been open. I can decide to, okay, you know, this is for the other one, so let me do 2. This is also 2. Let's see, so that you can see, well, 270. Yes, it's over 270. So this one makes it clear, so you can see. Yes, that's how it is. You can make it 180, so you can actually change the angle of revolution, right? So let's say 180 for the first one, and then I can decide to do for the second one too 180 as well. And then you can see what I'm trying to talk about. So let me check. Yes, okay, it seems. Yes, so now I hope you can see what I was talking about. Yes, everything. Yes, you can change the angle revolution. So this is a simple way of finding volume of revolution by using your GeoGebra. So thank you for watching and see you in my next tutorial.